Okay, welcome back everybody to our unit on polygons, and in particular we're taking a closer look at parallelograms, and then today we're going to look at a rhombus, which we're going to show to be is a parallelogram. So we'll start out with the definition. We'll have three theorems about rhombuses, and then we'll conclude that with an example. Okay, so you look at the screen there, you have the definition of a rhombus. A rhombus is a quadrilateral with four congruent sides. The definition says nothing about the angles. It just says a quadrilateral with four congruent sides. That would be a rhombus. Okay, so for the first of our three theorems, we're going to prove that a rhombus is a parallelogram. So you see rhombus A, B, C, D are given to us, and we're going to prove that that's a parallelogram. Notice I have the four sides marked off there that are congruent. And all we need to do to prove this is a parallelogram is quote an old theorem. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So you can clearly see that both pairs of opposite sides are congruent, and so that makes the rhombus a parallelogram. Okay, so our second theorem about rhombuses is that the diagonals of a rhombus are perpendicular. Okay, so what we're going to do to prove the diagonal is perpendicular is first of all say that, well, I'm going to look at, let's do this. I'm going to look at two triangles. I'm going to look at this triangle, BEA, and then triangle BCE. So we're going to prove those two triangles congruent. First of all, we know that side B, C, and AB are congruent because that figure is a rhombus. We know that BE is congruent to itself by reflexive property. We know that AE is congruent to CE because you know that diagonal AC gets bisected. That's why those two pieces are congruent. Diagonal AC got bisected because remember a rhombus is a parallelogram, and the diagonals of a parallelogram bisect each other. So that's why those two pieces are congruent. Okay, so now you can see those two colored triangles are congruent by SSS. And because they're congruent by SSS, these two angles here, which I'm going to put a little check mark here, those are going to be congruent by CP/CTC. Corresponding parts of congruent triangles are congruent. Okay, so I'm going to write that out. So angle AEB is congruent to angle CEB. Again, by corresponding parts. Okay, so if those two angles are congruent and they form a linear pair, which you could say they form a linear pair, that means they're supplementary. So if two angles are congruent and supplementary, that means they're congruent and they both add up to 180. So they're 90 each. And so we've just shown that these two angles here have to be right angles. So that means that the diagonals there, BD and AC, are perpendicular. Okay, our last theorem. Again, you see rhombus ABCD there. I've drawn in the couple of diagonals there. And this theorem says that each diagonal of a rhombus bisects two angles of the rhombus. So what I'm going to do is prove that these four triangles are all congruent. First of all, each of those four triangles has this side, because that's the sides of a rhombus. They're all congruent. We know that these two segments are congruent. Because diagonal BD got bisected, remember this rhombus is a parallelogram. And the other diagonal also gets bisected for the same reason. The rhombus is a parallelogram. And so you can see that those four triangles actually are congruent by side, side, side. Okay, so now all the angles that you see written in red there. So angle 1 is congruent to angle 2, is congruent to angle 5, is congruent to angle 6. Those are all congruent by CP/CTC. Those four triangles are all congruent. And those are the angles I wrote in red there that would overlap, and congruent corresponding parts of congruent triangles are congruent. Same thing with the blue angles there. So angle 3 is congruent to angle 4, is congruent to angle 7, is congruent to angle 8. Those 4 angles would, again, overlap. They would correspond with each other in the 4 congruent triangles. So they're also congruent by corresponding parts of congruent triangles are congruent. So remember what we're trying to prove. We're trying to prove that each of these diagonals bisects 2 angles of the rhombus. So you see that diagonal BD bisects angle ABC, this big angle here I'm talking about. So diagonal BD bisected that yellow angle ABC because angles 1 and 2 are congruent. And you can go all the way around the rhombus saying the same thing. So diagonal BD also bisected angle ADC, the yellow angle, because angles 5 and 6 are congruent. And you can also say that over here. But this time diagonal AC bisects angle BAD, the yellow angle, because 7 and 8 were said were congruent. And finally, you can go over here and see that diagonal AC bisected angle BCD, again, because angles 3 and 4 were shown to be congruent. So each diagonal of a rhombus bisects 2 angles of the rhombus. So that's our third theorem and last theorem of the day, and we just have one example to work, and then we'll wrap it up. So here's our problem. We're given that quadrilateral RSTV is a rhombus. And so we can apply any theorem that we have about rhombuses, or parallelograms really, to help us solve this. So one of our theorems said that the diagonals of a rhombus are perpendicular. So I'm going to find y, by the way. That's what I'm going to do first. I'm going to say that 2y plus 10 is equal to 90 degrees. So 2y is equal to 80, and y is equal to 40. Okay, we're trying to find this angle right here. So we're not there yet. We're trying to find this angle, which is a measure of angle WSR. Okay, so what we'll do next, we'll find this angle I marked up here, y plus 2. So that angle, so the measure of angle TSW is just the 40 plus the 2, that's 42 degrees. And we know that these two angles, the one I had marked yellow, plus the one I just found, those are congruent because remember that each diagonal of a rhombus bisects 2 angles of the rhombus. So both of these angles would be 42 degrees. Okay, so there you have it. You have your definition of a rhombus, 3 theorems for a rhombus, and an example. Let me review those 3 theorems because that's usual is our main takeaway. First of all, remember the rhombus is simply a quadrilateral with 4 congruent sides. And the first theorem we said was that a rhombus is a parallelogram. So remember that all the theorems we had about parallelograms also apply to rhombuses. Our second theorem was that the diagonals of a rhombus are perpendicular. So the diagonals of a rhombus form a right angle, are perpendicular. And then finally, the last theorem we had was that each diagonal of a rhombus bisects 2 angles of the rhombus. So there you have it. Let's get some practice, and good luck.